Here we go. Here we go. Now, that was a really useful, that was a If I don't use a mic, can you still hear me? Yes. No. Who can't? Were you joking or you really can't? I only give sensible answers. Funny answers are always good, but I need to know, is there someone that needs me to use the mic? Because if anyone does, I'm quite happy to use it. Okay. All right. Just go tsh if you don't need me to use the mic. Now that was a good, thank you. It was good. That was a good break because there were so many questions about the transistor thing that I just did as a really quick thing at the beginning that I've realized that a lot of people are slightly confused about it. And I will put a tute question in your tute next week, and your tutor will explain until your heart's content. In fact, I might make it the presentation question for next week. Something like that. I'll either make it the presentation question or put a tute question on it, and your tutor will explain it all. But let me say, it's not a key thing. I want you to know that, but your whole, like, it's not something you should freak out about. You should get it by the end of the course, and if it doesn't make sense now, you can just relax about it, okay? Because you don't need to understand it to understand the next thing we're going to do. So it's just something you should be very relaxed about, but it's really cool, and I'd like you to understand it, and there might be like a teeny little question in the exam on it, but it's not a core thing. Hey, you've moved. Well done. Everyone that moved during that break, that was awesomely good. You were stuck in there because you couldn't get out because of the camera, is that right? The guy at the very back in yellow? Oh, it was someone else wearing yellow. Aha. But so, and you didn't walk in front of that to come in? You walked in that side? Man. Okay, so everyone's got to remember, my name is Rupert. Please don't walk in maybe we shouldn't use the back row at all. What do you think? Yes. I will, just so you don't forget now, I will do this. I'm just going to gaffer tape your arms together. All right. Oh, no, I'm afraid you're stuck to that chair for the rest of the day. It's a fire hazard. Quick, someone give me a cigarette lighter and I'll burn it so it's gone. All right. Now, if anyone asks too many questions, this is why I have this tape. Actually, I really do like questions, so you can't ask too many. All right, so don't freak out about it, is my feedback. After this lecture, I will talk to anyone for as long as they need me to talk to them to explain everything you need to know. That's completely fine. Plus, I'll put it in the tute and make sure your tutor explains it to you until you completely get it next week. Okay. Now I want to use the language C because I want you guys fooling around with C over the weekend. So let's just turn the board lights off. Here's how I'm going to do it. First of all, let's pretend I don't have C on my computer at home because I haven't worked out how to do it yet because the tutes and labs haven't told you to do it until week 2. You don't have to do it till next week where your tutes and labs will tell you how to do it. Some of you probably already have it because you've gone to the home page and you've seen there's a link you can click on to install it and you've probably installed it and it might be fine. Some of you might have tried to install it, didn't work and are freaking out. That's fine too because it'll all be explained next week. Some people might not have tried it all. Okay. So I haven't got, this computer here doesn't have C on it, so how am I going to get to use C? Easy. I use this program called PuTTY. Does everyone remember how to find PuTTY? Where would I find PuTTY? Home page. Yep. Luke. Yeah, or Google. Yeah. Google's your friend. Here we are, PuTTY. Here we are. Click on that. That'll get it to you. Or CD, and the CD has PuTTY. Okay. All of those things work. Let's go back to where we were. So I've downloaded PuTTY onto this machine by clicking on that link. It's already happened in advance. And I double click on PuTTY and this complicated looking screen pops up. I ignore everything and I just type in here cse.unsw.edu.au. And I'm not even going to save it. And then I'm just going to go open. Easy as can be. And log in as, and now I better make that font bigger. Okay, let's do that again. I'm just going to adjust the behavior, appearance. The font is going to be enormous and bold. Okay. Now, all you do is you log in and you come to here and what do you type? cse.unsw.edu.au. Okay, you got it. Open. Log in as. Now I type in my CSE username, which is for me CSE guest 00. And the password Rip it. Oh, oh no! Right. I just misremembered the password. All right, so I've logged in. From my home machine, or my lectern machine, I'm actually now connected to CSE. Remember I said this whole setup's run by the uni IT people, nothing to do with my uni, my school, CSE, but now I've logged into my school remotely, and now although I'm sitting at a uni terminal, I'm actually logged into a computing, my computing account. So I've logged in as me, and you guys could all log in as you. And then I'm going to open a window, I'm going to edit, I'm going to move into what, I haven't taught you how to create directories, so let me just open an editor, and I'll open, what's the editor I use? Pico. And what am I going to call my program? Well, I'm not going to do Hello World this time. I'll do another one. Hey, Rupert. I'm going to call it week1.c just because it's sort of boring, but I'm thinking maybe I'm going to create one of these every week, so you could sort them that way. And this makes the file. It's a big empty file. It's just sitting there. And it's a bit too big, so let me just make it smaller. All right, and now I'm ready to write my first program. And the program begins with a comment. And the comment is, if I do a / line, that means what I'm about to write now is going to be ignored by the computer. It's just a comment for human beings. This is going to be a C program, and C programs sometimes get a bit confusing. Like you saw all those numbers we wrote up before in the machine code program, that was confusing. It's very hard to understand what that program did without following it step by step. C programs can also be confusing. So we write little comments which are little notes to ourselves throughout the program. So I'm just going to say, this is the demo code. We call programmer code sometimes. This is the demo code written in lecture 4, week 1, comp 1917. And then you say the author's name by Richard Buckland, and you say the date, which is 12th of the March 08. All right, so that's a little comment. The computer ignores it, but it's just making the program a bit clearer. And wherever I want to write a comment, at any point, if I'm writing the program, I can just go dit, and then everything after that's going to be ignored by the computer. Very convenient to do that. Do that a lot. So now I'm going to write my program. Now the program, if you remember, began with something like the program you've already seen started with /include stdio.h. Hash include, lines beginning with a hash are special in C programs. They mean, here's an instruction to the compiler. And hash include is, the instruction to you, compiler, is find the file called stdio.h and insert it in this point. So instead of me having to type a whole lot of stuff, whatever's in this file, stdio.h, gets typed in there automatically for me when the compiler gets to the file. So that saves me doing a whole lot of typing. And what it's typing in there is what it needs to know to use functions like printf. Std.io means standard I.O. The standard things you need to do I.O. I.O. means input and output. So the input is reading something in from the keyboard, and output is printing something to the screen. You might have noticed in our machine code, there's no way of doing input. There's only an output, which is very annoying. So I'm going to do some printing to the screen and some reading from the keyboard, so I better load in standard.io.h so it knows all about it. Was that a hand waving? Yes. Make it bigger. Ooh. Okay, I will. Change settings. I think I can change it on the fly. Yeah, cool. How about 18? Big enough? Even bigger. Okay. Thank you for saying that. That's cool. Because if one person can't see it, it normally means there's lots. So it's good to call out and tell me. All right, so we've included the file. That just tells it how to do I.O. So now it'll know how to do I.O. And then I start my program. And programs always start by saying int main int argc comma int argv. Oh no, what is it? Char star argv brackets. How's that? Now, I'm going to do something which is which I really hate doing, which is I'm going to say, just type that. Think of that as a special magic sauce that we add to the program to make it work. It's a special, it's got 11 different herbs and spices in it, and I can't tell you, I'd be fired from the uni if I told you what that meant. I'd like to tell you. And I reckon probably by the time we get to about week 3, I'll have lost my fear of being sacked and I'll tell you. But right from now, let's just assume that we always write that. The interesting thing to notice is the curly bracket here. C is one of what we call the curly bracket languages. Curly bracket languages use brackets to group things together. So what this is saying is the main function in my program is here. And here means everything between this curly bracket and this curly bracket. Yep, so everything between those curly brackets is my program. So I'm about to write the program. I'm going to indent by a certain amount because it's very nice to keep things, this tells me it all belongs to main. You can indent by however much you want as long as it's 3 or 4. And you've got to pick a number now, 3 or 4, and just think, I'm going to indent by 3, or I'm going to indent by 4. And then remember that number and use it in every single program you write this semester. So we thought it'd be nice to give you some choice and flexibility. We're not like ruthless and draconian, so you can pick either of those two numbers, but then stick to it forever. Don't use tabs, don't indent by 2, don't indent by 1, don't indent by 5, indent by 3 or 4. You got it, right? Why? That's a good question to ask your tutor, and we'll be talking about that sort of thing next week, right? Because the program would work if we didn't indent at all. So actually, that's an interesting question. If the program would work if we didn't indent at all, why am I imposing this really strict requirement on you that you must indent by 3 or 4? Because the program couldn't care less. Who cares? Yes? Makes it easier to read. Who cares? That's great. People reading it care. The computer doesn't care. We care. The readers care. Your tutors who are marking your programs care. Yes? You can't use tab. Ask your tutor. Yeah. It's a good question. See if you can guess what their answer is going to be. You've got like, depending when your tutor is, somewhere between 10 minutes and like a week to think of the answer. And I bet you can work out the answer before you ask them. Okay. So now we're going to write our program. We're just going to print something on the screen. The command for that was printf. F means what? A formatted thing. Yeah. You had no reason to know that if you couldn't already program in C. Printf means print it out and print it in a special format. And the format I'm going to use is, I don't know, print I have %d chickens \n. So this is the format. I'm telling it what the output's going to look like. It's going to contain the words I have and chickens. It's going to have a new line at the end, and it's going to have a number in there. D means it's a decimal number, so it's going to print it in base 10. What number? How many chickens do I have? Does anyone know? I don't have 2 chickens.
12.
I don't have 12 chickens. I have a number of chickens. It's a legal indent amount, and it's odd.
13.
3, 1. They're not owned. Indent by 13. That would be terrible. Look, if you indented by 13, here's what your program would look like. If you indented by 1, that's what it would look like. That might not look so horrible to you if you haven't programmed before, but programmers hopefully watching this will be going, oh my God, what's he done? So, okay. Okay, so I have 3 chickens. That's going to print it out on the screen. Now I want to compile that program and test it. I don't want to do any more typing until I've tested this thing. How do I save it? Control O, accept the name, just hit enter. I've written the program out. Now I'm going to run it. I'm going to compile it. I don't want to close this editor window. It's really convenient having an editor open, so I'm going to open another window in PuTTY. Do you remember how we do that? We go cse.unsw.edu.au, and I'm going to be doing 2 things in parallel because I'm from Generation Y. No, I'm not. You are. Oh, we've lost our font size. Login as CSE guest 00. Password was okay, CD, and then I'm going to compile it. Oh, and this font isn't big enough, so let's make the appearance better. Where is it? I've lost it. Change settings, thank you very much. Appearance, change, what did we make it, 20? Bold. Comic Sans. What is it with Comic Sans? Why does everyone like Comic Sans so much? It's... Okay, all right, now I'm going to compile it. What's the command to compile it? I've written a program, a C program. I now want to convert it into machine code. I'm going to go GCC minus wall minus O. What am I going to call this? Chickens. That's a good name. Chickens. I've left something out. Oh no, I put the input file after all the options. So it's, is it lowercase w? I am using tab, it's not finding it. There's two of them, that's why. Okay, so I'm GCCing wall negative O chickens week1.c. Oh, control reaches the end of a non-void function. No, so what's happened here is I tried to compile it and I've got an error. A warning is an error. If you get a warning, it's an error. In fact, here's how we should compile it. Where? Yes, thank you. There. Where means if there's a warning, treat it as an error. Because a warning is an error. A warning is a compiler saying, are you sure you meant to do that? And whenever the compiler is doing that, it's a polite way of saying, you've stuffed up again. So you might think, oh no, I can ignore that warning. It's like when it's going like, beep, 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 dangerously low on oxygen, warning, warning. Do you think, that's okay? Yeah, okay, so when we hit an error like this, what do? We are relieved and relaxed because it means everything's okay. If I hadn't got an error then I'd have been alarmed.
What's the difference in those responses though? For when you
None. No, that was my joke. That was my joke. Yeah, that's a very crappy joke, sorry. But if I'd had a program which had a whole lot of warnings in it, oh no, there is a difference. With where, it won't have actually generated that file called chickens. So if I hadn't put where in, no difference this time because the first time I ran it, I didn't have where in there. So it would have generated chickens and it's warning me, I've made the program for you, but it's a bit dangerous. But with where, it goes, I'm not even making that program. Yeah.
It says up the top there, warnings being treated as errors.
Warning, that's the other difference. Warnings being treated as errors. See, it tells you to treat warnings as errors. It's a nice little reminder. No, I'm just being silly. Okay, so when you get an error, it's okay, you don't freak out, you just relax, you think, okay, I've got an error, I expect to get an error, and I'm just going to be calm and solve the error. The important thing to notice is the number 11 here. That tells me it thinks the error's on line 11. That's a good place to start looking. It's not always right. In fact, probably even 50% of the time it's not right. But it's a good place to start looking. It's reached the end of a non-void function. Oh, what does that mean? I've got a function, it's reached the end of it, and I notice, oh, this function said int main. What that means is my main function is expected to return an int. An int means an integer or a number. This program's expected to return a number. So I'm now about to introduce the return command to you that says, here's the number I'm going to return. So whenever this program runs, it returns the number 0. We won't get to see the number 0. It's just going to give it to the computer, and the computer can choose to do what it wants with it. The operating system can do what it wants with it. But I did promise an int. That's what this line that has a magic source on it contains, a promise that it's going to return an int, so I better put the int in there. Now let's compile it again, clicking across to here. And now let's run it. I'm going to run it. It goes, I have 3 chickens. All right, it worked perfectly. So everything's as we expect. We got one error. It was a program that had one line in it, really. You'd expect to get one error in a program with one line. That's about a good ratio. So we're just feeling all relaxed and everything looks right. We're able to fix it up. We're all calm and relaxed. Everything's cool. Often you'll find programmers, when they're not sure what the error is, they'll just change things here, there and everywhere and recompile to see what happens. That's obviously not rocket, brilliant, neutron science way of solving problems, but it's not a bad way. So if you're completely stumped and don't know how to try to solve a problem, just try something and recompile and try it out. Never freak out completely. Just always keep moving forward. Always try. Never give up. But, all right, so this is our very simple program, but it's not a very interesting program because some of us might have different numbers of chickens. And yesterday, one of my chickens escaped. We were trying to clip its wings. It flew away. It didn't want its wings clipped. My children were watching that looking horrified. And I was thinking, there's a metaphor in this. But I didn't tell them about growing up and becoming teenagers. and how I'm going to keep them locked in their room and not let them date anyone, ever. So, yeah, there you go. Okay, I'm a bit weird. So, we want to print out how many chickens we've got in case one does run away and we can never find it again. So let's say, how many chickens do I have? What would happen if I didn't put \n there? Yeah, the lines wouldn't go onto different lines. Let's have a look and see. Have a look at that. Let's try it out. Compile it. Run it. How many chickens do I have? I have 3 chickens. Well, it's all right, isn't it? It doesn't look too bad, but that wasn't our intention. Our intention was it's going to be on 2 different lines. So \n. Let's compile it. Fix it. Compile it. Run it. How many chickens do I have? I have 3 chickens on separate lines. That's looking good. Okay, now I want to actually read in how many chickens I've got. And to do that, well, let's not read it in. First of all, let's do the weird sort of thing we did in the machine code program, where we actually tell the program how many chickens we've got. Like before I said, I want you to print the number that's at address 15. And we already knew what that number was, so it might have seemed a bit pointless to do. Let's suppose I'm going to say int, what should I call the place where I'm going to store how many chickens I've got? What's a good name for that? The coop. I could say int chicken equals 3. And how many chickens do I have? I have chickens. All right, now here what this is doing is this is creating a variable, like our address 15 before, where we store that number was a variable. The variable is going to store an integer. Remember what an integer means? What's that? It's a number. It's a whole number. It doesn't have a decimal point. And I'm assigning the value 3 into it. So wherever you see the word chicken in the program from now on, it's going to be thinking I'm talking about this variable which has a value of 3. So where it says I have %d chickens and it sticks in chicken here, it's actually going to stick in the number 3. Does that make sense? I didn't explain it very well. I had lots of chickens in the explanation. Yes?
If chickens is in the sentence,
yes.
Does it do...
Good point. Well done. If this had the word chicken in it, do both of those get replaced with the number 3? The answer is no, because that's what we hope the answer is. The answer is no, because this message here is between 2 quotes. And anything that's between 2 quotes is called a string. And a string is literally kept by the computer. It thinks that's literally what you mean, and it'll never change that. So that's a string, a series of characters that never changes. Whereas this here is an instruction to the computer. It's part of the program itself. Does that make sense? Yep. Okay. So let's just do this and you'll see that it works. Okay, so here we go. We'll compile it. And we'll run it. How many chickens do I have? I have 3 chickens. That is a beautiful... That's all right. That's all right. That's all right. So here we are. You see, what have I done here? We've printed out I have that many chickens. And we only printed out the word chicken. I wanted to put the word chicken in there so we'd see that it didn't get replaced by 3. And so it's missing the S. So I didn't put a new line there. And that means the next thing I print will be printed immediately afterwards. And then I stuck the S in there. Does that all make sense to everyone? Yep. Any questions? Yes. Oh, okay. I wanted to put the word chicken in the string just to show you that the chicken wouldn't be replaced by 3 if it's in a string. But I wanted to print out the word chickens with an S on the end. So how we did that was we printed out chicken, then we didn't drop to a new line, we didn't put a \n in, and then I printed out the S down here. And then I did the new line. Yes? I didn't hear the first part of the question.
When you compile it,
yes.
compile code, you have chickens week 1.c. I understand.
Oh, the line of, hang on. I think you're talking about on the other screen.
Yeah.
This says, take this file here and produce a new file called chickens. I'm going to draw a picture of that because that's such an important sort of thing. Yep.
Is that a standalone file of chickens?
You can call it whatever you want.
I'm saying, like, can you run it?
Yeah.
Other programs?
Yeah, it's a program. Yeah. Let's have a look, guys. I write a program called week1.c. It contains my C program. It's a file, just like a file you make on your computer normally. It's called week1.c. I've got a computer chip over here with little legs on it. It doesn't understand C, it only understands machine code, which looks a little bit like we were fooling around with that pretend machine code we've got. It only understands numbers. It doesn't understand the language C. So we need to convert this into a lot of numbers that it can understand. We need to convert this into machine code. How nice it would be if there was a program that could magically convert a program written in C into machine code the computer could understand. And there is. The program that converts C into machine code is called a compiler, and the one we use is called GCC. So GCC converts the C code into machine code. The file that we put the machine code in we called chicken. Once we've made the chicken file, we can run it on our processor by typing ./chicken. And then the computer runs the chicken file. Does that make sense? So it's a two-step process. You write the program, you convert it to machine code, you run the machine code. So that was an excellent question. And it makes sense? Yep. And we didn't have to call it chickens. Certainly the word chicken is appearing too many times in this example. It's getting confusing. All right. But, oh yeah, thanks. Suppose we wanted to have the ability to change the number of chickens. I can do this. Scanf. Scanf means read in. The F means format. It expects a format string. Okay, read in a number. %d means a number. And where am I going to store that number? In chicken. Now, second piece of magic sauce in this lecture, I have to put an ampersand first to store it in there. And we will explain that next week. And what's it called? Chicken. No, I don't like that name, chicken, by the way. There are too many chickens in this program. It's really the number of chickens. Who said that? Well done. The name of something should represent what it means. In a program about chickens, a variable called chicken is just confusing. Of course it's something to do with chicken, because it's a program about chickens. We need to know, the important thing is it's the number of chickens, not the height of the chicken or the type of chicken. So it's number of, it's the most important thing. So a good variable name would be number of chickens. Now it's absurdly long, but it's clearer. An even better name would be shorter and equally clear, but this is better than the last one. So I'm going to call it number of chickens. I have %chicken. I'm going to get rid of that because that was just confusing what I was doing there. That's just gone. If I wanted to get rid of this line, but I didn't know if I might need it back one day, how could I do that? I could just comment it out. Now the computer can't see that line, but it's still there. I have %chickens, and what do I say here? Number. Now we're glad we didn't indent by 11 because, you know, we'd be not able to have these ridiculously long variable names. Number of chicken. It wrapped around, so I have to go back. All right. Does everyone understand this program now? Oh no, I didn't tell it. Store it in number of chickens, please. So read it in from the keyboard. %d means I'm expecting to read it in integer. Store it in number of chickens. Thank you very much. Let me move that program to the side so you can hopefully still see it. And I'll make this one a bit smaller so you can see both at once maybe. Can we almost do that? And now I'm going to compile it again. And I'm going to run it again. How many chickens do I have? 7. Thank you very much. I have 7 chickens. Okay, cool. So we've got a program now that reads in and prints out. And you can fix a clock. Well, no, but you've seen someone fix a clock. I mean, it's very similar. And we've got a few minutes to spare. So does everyone understand that? Questions, and then I'm going to show you the next most amazing thing. Yes?
Why did you do the capitals?
Ah, good question. Very good question. C is a computer language that cares a lot about whether things are uppercase or lowercase. If I wrote number of chickens capitalizing those words, and then I wrote number of chickens not capitalizing those words, it would think I was talking about two different things. So once you've worked out how you're going to capitalize something, you have to stick with it. Is not case insensitive. I might just taking hours to say something that can be said really simply. So it's really important to get the case consistent once you pick one case. Now, why did I pick that? Why did I pick that particular case with the first word started with a lowercase letter, and then every subsequent word started with an uppercase letter? That's known as camel case because it's like got humps in it, like a camel. Every time you start a new word, you do an uppercase letter. You have to follow some convention when you have multiple word variable names. And there are many different conventions you could follow. But if you don't follow any convention, you're dead, because you'll be halfway through your program and you'll suddenly think, oh, I need to know the number of chickens. And you'll type in number of chickens and you're suddenly realizing, is that number all in lowercase or is it uppercase? Am I using underscores? And you go back and you have to look to see where it was defined before, and you'll always get errors because you. So it's much better if you just think, oh, I've got this mindless rule I always follow, that I always do it the same way. And then it always works. Like for me, for example, when I write a variable about colour in a program, it's very confusing because there's two ways you could spell, there's many ways you could spell colour, but there's two generally accepted ways you could spell colour. One with a U and one without the U. I live in Australia. Australia is really just part of Britain. So we love the Queen. So you would think I should use the letter U in my word spelling of colour. But years ago I decided I was just always going to spell colour without the U, and that was a convention that I would follow forever. So now when I'm writing colour, I don't have to think, oh, did I spell it this way or that way? Because otherwise, worse, you could end up with two different variables that you think are the same variable. You create one with one the other, and you update your colour, and suddenly colour's not updated. So I always spell it the American way. Why? Oh, well, because most programming languages and other things and code comes out of America. So if I have to integrate with other people, they've always spelt it without the U, so, you know, I don't know.
Would it give you an error though if you tried to write or read from a variable which hasn't been?
It will give you an error if you try and read or write from a variable that you haven't written out correctly. That's right. The danger is you could accidentally declare it twice, spelt differently, and then it won't give you that error. So that error is like a seatbelt. The error warning, the warning error thing that you get is like wearing a seatbelt in a car. If you put it on and you have an accident, it might help you. But no one would ever think, oh, I've got a seatbelt on, now I can drive like a lunatic. Well, no. You're all 20-year-old. Okay. But in 10 years' time, because in my dim distant past, I used to do some work with an insurance company analysing crash statistics. There's this amusing thing called the curve of deaths. Has anyone ever seen the curve of deaths? You plot deaths by age, by gender. And the curve of deaths looks something like this. If this is the number of dead, and this is the number of people, no, this is the age, then the curve of deaths is quite high when you're born, like there's a high sort of infant mortality, then it drops very low, and it slowly gets higher and higher until you're like about 50, or 70, 100 or something. Sort of like that sort of curve. Oh, that's the curve for women. The curve for men is identical, except... And between about 17 and 25, men just die like flies from car accidents, and it's completely freaking. And actually on the girl death curve, there is what we call the passenger hump, which there is a slight hump carried across there. So if you're a guy, which you'll know that yourself, please be careful when you drive, because just there's this brief period of time where you do think you're immortal and you're slightly insane. When you get to my age, you're just slightly stupid, and when you're sane again. Oh, I think I'm... Well, you know. Yeah. Okay. You get the idea. Okay, so what were we answering? Well, there was a question we were answering. Chickens. So you follow convention, follow case, stick to it, curve of deaths, car accidents, completely forgotten it. Maybe we could rewind and watch what we're up to. Yes, do you remember? No, you don't.
Oh, seatbelts.
Seatbelts. Oh, yeah, seatbelts. I think it's back in a sec. So seatbelts. Wear a seatbelt does not mean you can drive like a lunatic. It might help you or it might not. Compiler warnings are like that too. When you get them, you're always so grateful because it means that there was an error in your code and it's found it and told you about it. But that's only a fraction of the errors in your code. Your code will have hundreds of errors in, and the worst ones are the ones it doesn't even tell you about. So you would never relax and think, oh, I can just type case however I want and the compiler will pick it up. Usually it will, but you can think of catastrophic events where you accidentally declare it twice with the different spellings and then won't pick it up, and then, aha, you're dead then. You go, I did update it, I added 1 to it, it hasn't changed. I added 10 to it, it's not changing, what's going on? It's because one's spelt this way and one's spelt that way. They're actually different things. So going back to your question, why do we pick camel case? So it's important to follow a convention, it's important to follow case. Why do we pick camel case? It was a more or less arbitrary choice. A lot of C programmers use a case convention that looks like this. So you write this is a variable, all in lowercase, underscores. That's one legitimate convention a lot of programmers use. The one that's used in Java, and this course is feeding into a Java course eventually, so we decided to stick the whole, is you'd write this is. Problem is, with single letter words, you see, it looks stupid, variable. So it doesn't work, camel case doesn't work quite so well. But it is a bit shorter and terser, so yeah, so camel case is just what we use. It's in the style guide for this course, so we'll expect you to use camel case. In your own programming course, you use whatever you want. Phew, that was a very long answer, but to a very important question. Yes?
I was just looking at the PuTTY, you know the scanf, you have
Yes.
an and symbol there.
Hang on, let me go back.
You
Yep.
have an and in front of,
The ampersand, yeah, magic. It's a second piece of magic, and I hate doing this. You'll just have to wait a week or two till I tell you about that piece of magic. You have to have that when you use scanf.
It's like storing that variable.
It's exactly what it means, storing that variable name. It's not exactly what it means, that's the effect of it, yeah. I really want to tell you exactly what it means, but it would be an even longer diversion and less amusing than the story about car crashes. So we'll wait till week 2, but we will explain it eventually. I agonised about putting scanf in the course for that very reason, but I need you to be able to input data, so we've got scanf, and I just have to say, believe me, an ampersand goes there, it will all become clear very, very soon, and you'll understand every single reason why it's there. Yes?
So if you change the number of chickens,
Yes?
at the end of printf on that third line,
Yes?
you have to change that one as well.
If I change, that's a good question. If I change the number of chickens here to what?
No, that's right. Keep going down.
Yep,
Yeah, number of chickens.
yep,
Like one more down and over.
Yep.
On the right. You have to change the one after the and symbol as well.
yes, yes. If I change the name, you mean? If I change how I spelt it or capitalised it?
The two things are the ones that are connected.
Yes. No, these three are all connected. This sets up a variable called number of chickens. And it says this will store an integer. And it says initially it has the value 3 in it.
So if you don't write anything, it's going to write 3, but if you write 7, it's going to try to be 7.
You got it. No, no, no. As soon as I get down to here, whatever I type in is going to overwrite what's in the 3. If I don't type anything, it's going to get confused because I've told it I'm going to type in a number. So this number is never used. It's always overwritten.
Unless you say 3.
Unless you typed in 3 and then it'll be overwritten by itself. Exactly the same as a program we did before when I had that 0 in the program that got overwritten by what we were printing out just after the 8.
You don't even need that line anymore.
So I could simplify this line to just say that. When I set up a variable, oh, are we close to the end? No, we've still got, I believe, 10 minutes. Does everyone else believe that? Yes. Who asked that question? Was that you? Luke? Who was asking the question? Oh, it was Luke. When I set up a variable, I've just set up a variable here called number of chickens. There's 2 things I have to do. One is called declare, and one is called initialize. And declare is when I just tell the computer that it exists. I say, hey computer, I'm going to have a variable called number of chickens. And it's going to be spelt like this, and it's going to store inside it an integer. I've declared it, and that's what the line does at the moment. And then initializing means when you give it its first value. So I could say underneath it, I could say here, number of chickens equals 7. So this has declared number of chickens, so the program now knows about number of chickens, and it's given it an initial value, which will instantly be overwritten by this value, and then printed out down here. And all 4 of those have to be the same. And the trick I did before was I declared and initialized in one line. I did this. Do you remember? I did. Huh? You can declare and initialize in the same line. Okay, that's a lot. That's a lot of chickens. Yeah. They're laying eggs, but I can't find them. They're somewhere. Okay. So, were there any more questions? All of those questions were excellent. Thank you to everyone that asked a question. Yes.
If we didn't have scanf, would that
Yeah.
then override?
Now, when there's ever a question, if we didn't, what should I do? Try it out. Cool. So, if we didn't have the scanf line, what's going to happen? What about this? Here's a crazy program. What value, what's it going to print out? What's it going to print out? Okay, so it got given 42, then it got overridden by 7, then it got read in. Let's just check it though, don't believe me. let's see that it's going to have 42. Its initial value is 42. Let me move that to the side so you can see it. So I'm going to compile it again, run it again. I have 42 chickens. That is a lot of chickens. But you know, I'm surprised no one suggested I have a minus number of chickens. I have a fractional number of chickens. I can't do that because, why can't I do that? I can't do that because A, it's an integer here, and B, it prints it in, it's expecting an integer here, and C, it's printing it out as an integer here. So that would, what would happen if I did that? No, what's the answer to that question? Try it. Let's try it out. That's the answer. Let's try it. Hopefully we'll get a wearer. Oh no! Oh! I know what it did. Okay, yeah, let's run it. I have negative 42 chickens. C does this really annoying thing. It really grates. It does this thing where if it's got something of one type and it's expecting something of another type, it just changes it without telling you, secretly. So if it's expecting an integer and you give it a decimal number, it just thinks, oh, don't worry, I'll fix that up for you. Now, it is neat because it means you can be a bit sloppy when you're writing and it'll fix things up for you. Why is it not good? Why is it not good that it's silently correcting errors that it notices you've made? It might correct them in the wrong way. Is that what you're both going to say? Yes, a hand from here.
It also, yeah, it corrects them and it might be making you error.
It might be making it, it's a computer, it's stupid. I'm a programmer, I'm stupid. It's a computer, it's more stupid. So if it silently corrects my errors, what it's saying is, you've made a mistake, but don't worry. I'll fix it all up. Now maybe that'll be okay, and maybe it won't. What were you going to say?
Just a small thing.
Yes.
I think the percentage sign D means double.
Oh, does it? A double, not decimal. Yeah, double. No, that's L. That's L.
D is decimal.
D is decimal, LD is.
Read man print.
Shh. We'll try it out. We'll try it out later on. Yep.
Instead of typing in a decimal, why don't you type in a string like
Oh yeah, cool. Well done. Okay. Now, can I just say, can I give you guys a bit of amusing homework? Oh, it's actually tragically sad, but it's also amusing. As an example of what happens when someone writes a program in C and they get a type wrong and the computer corrects it automatically, Google for Ariane. Ariane was the European attempt to join the space race. It cost them, does anyone know how much the Ariane mission cost? Yeah, how many heaps? Yeah, it cost a lot of money, billions and billions of dollars. And if I was to draw a trajectory of the rocket, I want you to look it up. All of Europe saying, we're going to join the space race, we're going to be so cool. And they built this enormous, expensive rocket fueled by money. It cost so much to build this rocket. And if you were to look at the trajectory when it launched, it went something like this. And all the money just fell out and was lost. And that was due to one line of C code where the type was wrong and the compiler said, don't worry. So yeah, okay. Okay, so, oh yeah, no, someone, how do you spell Ariane? I don't know. Ariane? Google, spell check it. Yes?
when you compiled it, how did you need to compile the whole thing out again?
Oh, I just hit the up arrow key. If you hit the up arrow key, it remembers what you typed last. I think even Windows does that now, I think. Does everyone think it does? Yeah. Are you here for the next course? Okay, that's all right. Is it geology or something?
I had maths.
Maths, it could be maths. Yep, that's cool. So you're slightly early and welcome, and you can join that last few minutes of us. So we're just about to finish, guys. Someone did want to try what would happen if it's a string. No, I'm not even going to do that. What I want you to do is I want you to try it at home, because I did want to show you one last little thing. What's that? No, good question. You don't have to initialize. It does have to be initialized before you use it, but it doesn't have to be initialized when it's declared. So I could have left the initialization out and it would have been initialized by the scanf, and that would have been fine. That's a good question. And also another good answer would have been, hey, that's a good question, try it and see. That's another good answer, but that's a really good question. All right, I did want to show you one last thing. So any more questions now? Ask me at the end of the lecture. I'll lurk out the front. You can ask me questions as long as you want. But I wanted to show you one piece of syntax, which is this. Remember we had a program before that said if we entered a 0 we wanted a beep or something. Here's how we do it in C. We'd say if the number of chickens is equal to 0, curly brace means I'm starting a bunch of stuff. I better put the closing one in so I remember to put it in. Everything between that opening and closing brace will get executed now if the number of chickens is equal to 0. And what am I going to printf? Thank you. No, it wasn't beep. What was it? Bing. Whoever's got Bing. It's Bing. I'm being Groundhog Day. Now, anyone that's got Tim, please hassle him for not getting beep right. Let's just go here. Ding, bing. I think I was just doing Groundhog Day. It was my little joke. Okay, so now we're going to jump across here. That's the if syntax. I want you to know it because you'll need it for next week. We'll compile. There's no error message, so already I'm faintly alarmed, but let's just go on thinking maybe the error I've made isn't so serious. How many chickens do I have? I have 0 chickens. Bing! I must have commented out the scanf. Did I? Yes, so I didn't ask for one, and the default value was the value initially loaded in, which was 0. Okay, so that's called an if statement, and if you want it to be really fancy, you can also say... No, you can't ask the question, because we're and if you put else in, if it's not 0, it'll do this. Print, pring, bong. Okay, you guys try that out. I'll see you next week. Questions, just ask me down the front. Ask me 2 billion chickens. Man, I've got to get an egg with 3 billion chickens. Okay, see you next week. Have fun, everyone. What's that?